let's talk about squared. 2 squared, or 2 times 2 equals 4, is a representation of an area model. So if you look at 3 squared, or 3 times 3 equals 9, we're saying that the height and the length of it is equal to 3, but the area of that together equals 9. Same thing with 4 squared, or 4 times 4 equals 16. The height of it is 4, and the length of it is 4, so therefore the area of it is equal to 16. So same with the 5 squared and the 6 squared. If you look at the length and also the height of it, it equals the area model of it. Let's talk about the square root now. So square root is going the opposite of the square. So when we talk about the square root of 4, we're saying that the area of that square is equal to 4, but what is the length of it, or the root of it, which equals 2. So if you go square root of 9, we're saying the area is 9, but what is the length or the width of that square, which equals to 3. Square root of 16 tells us that the length and the width of that square is equal to 4. And square root of 25 tells us the root of that square is equal to 5. Square root of 36 tells us that the length and the width, or the root, is equal to 6. Now, square root of 8 is not a perfect square like we had with the examples of square root of 4, square root of 9, square root of 16, square root of 25, and also square root of 36. Each of those had the same sides. Square root of 8 does not have the same side. We factorize it, so we say 2 times 4 is 8, and 4 is not a prime number, so we do 2 times 2 equals 4. So now we list out all the factorizations of 8, which is 2 times 2 times 2. And we go ahead and we look for the little index number, which we call a 2. So we're looking for 2 of the same numbers. So in this set, we have is right there is one group, and the other one's right here. Okay, so we have 2 square root of 2. So another way to do this is I call it an inverted division, or a stackable. So with this 8, we go into a prime number, which is 2. So 2 goes into 8 4 times. 4 is not a prime number, so we go another time. 2 times 2 gives me 4. And the last 2 on the bottom is a prime number, so we know when to stop. So doing the same thing for the square root on the previous problem, we're looking for 2 of the same numbers, and then the leftover number is inside the radical, in our case, square root of 2. So now this time, let's go ahead and model our square root of 8. So my layout is 8 blocks right here to represent our square root of 8. Now go back to the definition of a square. We mentioned that a square has to be of the same length and the same height. So if I have a square root of 8, I would have to have the same length and same height of something, right? So then let's look at our chart. In our chart, I have is 2 squared is equal to 4, so that means I would have to have 4 area. And 3 squared is equal to 9, that would mean I would have to have an area of 9. But we have an area of 8, so we can't use a 3 by 3, so we'd have to do a 2 by 2. So we're going to go ahead and form a 2 by 2s, and let's see how many groupings that we can form of a 2 by 2. Okay, so I have is now 2 groupings of a 2 by 2. So in a model format, the outside number is the size of our squares, in this case 2 by 2, and then the inside represents the number of groupings that we have. So in this case, we have 2 groups. So therefore, the square root of 8, the 2 outside represents the size of the square, and the inside represents the grouping, which is 2. So square root of 8 is 2 square root of 2. So now let's try the square root of 18. So I'm going to go ahead and add 10 more of the blocks, but in a different color. This color is green, so that way you can see what was added onto it. Okay, so we already have is the 8, and we're going to have is the 10, which is added onto it. So doing the same thing, what is the square root of 18? We want to go ahead and start looking for is what is a good square size. Well, since we've already started with a 2 by 2 on a red, if I do a similar idea with the green on a 2 by 2, what happens is I have 2 left over. So that is not a good size for this problem because we can't have any leftovers. Our groupings need to be of the same size. So let's think about this. possibly we can do like a 3 by 3. So let's go ahead and try this out. And if it doesn't work, we can always try something else. But I'm going to go ahead and make a 3 by 3 out of this. So we're going to add onto it the green piece to the red piece so that we can see what was been added onto it. Okay, so this is looking good because all the pieces are coming together. And remember, it has to be the same size. So we have two squares that are exactly the same size. It's a 3 by 3. So in our square root of 18, the size on the outside represents the size of our square, which in this case is 3, and the inside of the radical represents the grouping. So in our case, it's groupings of 2. So square root of 18 would have to be a 3 square root of 2. Let's try square root of 20. So if we add 2 more blocks to this, we're going to find that we can't just go ahead and stick them to the 3 by 3s that we have, right? Because then that's not going to create a square shape right there, okay? So we need to figure out is how can we break it down so we have squares and that are evenly groupings of. So this tells me that a 3 by 3 is way too big, so I'll probably have to break it down to a 2 by 2. So let's go ahead and break this down to a 2 by 2. I'm going to go ahead and keep the red the way it is because I've already formed the 2 by 2 with the red. So I'm just playing with the green right now. Okay, so far we look good here. So now we have these guys which are left over, and I can put the new blocks to this, and that will give me a 2 by 2. So perfect, we got groups of 2 by 2s in here. So then square root of 20 will give us a 2 by 2 square on the outside, square root, and the number of groupings inside is 1, 2, 3, 4, 5. So it will be 2 square root of 5.